So there's two of us who are actually going to cover this topic today. There is myself, Mirek, and then there is also Josh Gordineer. Josh, right there. So what are we going to talk about? We are going to cover what and why of YQL, a brief history. That history will essentially cover where we've come from and where we are right now, and what does the usage look like. We'll also overview some features, the features that are sort of most powerful that let you get to work with YQL. And I'm just going to step over those features fairly briefly, and that segues into Josh's part, where he'll focus a little bit more into how to work with YQL. He'll cover tables, he'll cover open data tables, he'll cover some nifty features in his presentation. So the whole jest here is, why even have a solution like YQL in the middle? So what is the problem that we're attempting to solve, or that we have solved with YQL? And what the solution looks like, which is really the set of features, the detail that I'm sort of going to go through. And every one of us, most of us for sure, are concerned with application development. What is application development about, and how do we get to the application? How do we get to putting something in front of the user? Because that's really the gratification stage, where we get users to interact with whatever it is that we create. For an application, you have your awesome application idea. That idea starts with something in your head and is going to require data. Aside all the user interface, which is very important, how does user interact with your application, there's always a data flow, data exchange, whether it's in the form of input or whether it's really in the form of return as a result of that input from user, search, and so on. So today, writing an application, or yesterday, or in the world before YQL, it involved fetching data from multiple sources, yourself straight from your application. And that meant essentially going after these sources yourself. You would go ahead and create a data wrapper for Flickr. You would create a data wrapper for search. You'd create data wrapper for some geo information. You'll create a data wrapper that handles reads and writes for your state information about a user. Not only that, but in a client world of development, where JavaScript sort of shifted to the client in terms of powering the actual user application, you have to deal with proxy, which is some sort of middle layer where you enable that application. And then if you multiply it times number of your projects, you end up with all that extra layer of work and cost that is essentially slowing you down from focusing on what's most important, which is innovating with your application to satisfy and sort of enable your users. So the problems are not only multiple data sources. You have to consume an individual spec for each of these data sources. You have to get familiar with the Flickr data source and search data source, and so by the end of the day, you really are good with all these data sources. The problem there is you have to keep track, and you have to sort of stay in step with all of that. Once you've gone past that stage, then you have to deal with multiple connections from your application. That may or may not be a problem in general, but again, it's a question of how often do you want to constantly worry about that? And is this really a drag on your development time? The changes I mentioned. And the last thing is, if you ever wanted an arbitrary data source to work with, we have to come up with a way to consume it, parse it, and deliver as an API all by yourself. So another cost element for you to consider in the application development cycle. All of this is time, all of this is frustration, and sort of shifts focus away from where you want to be, which is innovate and deliver cool stuff to your users. So let me enter a solution. It's called YQL. So we still have this my awesome application idea. We still got that right there, front and center. But now we're going to enter YQL. enter YQL. And with YQL in the middle, you are entering or adding a box, entering a service right in the middle, which does a lot of powerful stuff for you. It takes away the multiple connectivity worry. It takes away the worry about multiple documentations. It adds something that we are all familiar with, which is SQL-like functionality right on top of your data layer. As you'll see later on, it adds extensibility, which means that you will be able to leverage the strength of community to really focus on your application development cycle. Not only that, that community will iterate and version the data sources for you. Each of these arrows below YQL represents a binding definition. YQL has a concept called table, where you define your downstream source and downstream source bindings among some of the elements or some of the configuration options. This abstraction layer lets you really focus and leverage the power of the data through YQL in your application development cycle. Not only that, let me reemphasize, single API spec is all you worry about. And on top of it, it's really familiar. There is some other things which is sort of interesting, which happen underneath the box or in the box, which is optimization of requests, caching, and all that performance stuff. So let me zoom in on that box right in the middle and sort of take you through what are some of the features and some of the cool functionalities that you can work with in YQL. Let me just make sure that the basic stuff here is the YQL statement, the most fundamental stuff that you get to work with. There's a zone, there's a dead zone here somewhere. That you get to work with is the YQL statement. That's kind of how it looks. It's very familiar, and it's very descriptive. You can show your tables, and you will go through that, how it looks. Gesundheit. We'll cover, you can describe a specific table, which is the information that accompanies table, which again, very easy to sort of work with as you go through this. There is the power of select to fetch the data. There are also these additional verbs which you would expect to have in a SQL-like language, which is insert, update, delete, to modify data. And then there are these additional keywords to use specific table definition that you work with, and the set define key values across open data tables. And those will be covered a little bit later. At the bottom, you have as a motivation sort of a fairly complex statement that shows you the functional capacity of YQL and the ability to go across multiple data sources to operate as a single query. So what are some of the features that you can expect in that box which sits in the middle, that does the work for you, that empowers you to develop your own application? Well, some of the features are what you would expect, which is filtering, paging, and projection. Table data can be filtered in the where clause. So right here, you'll see that there is some filtering going on. In fact, throughout this statement, there is a filtering going on. You've got your remote filtering in a where query, which is applied to that specific table, which abstracts an actual service endpoint. That query will get sushi for a location San Francisco. And then locally, we're going to apply a filter on rating. So we're going to compact that data that only meets certain criteria. So imagine how much work you'd have to do if you were just to extract a subset of results, and how easy it looks actually if you were to look at how YQL deals with this. And then you can chop. Now, that obviously isn't too hard in general, but hey, we can do it for you as well. So data out of the YQL system right to your client is that much thinner, which means usually a lot more faster. So there is a little bit of a concept around this whole problem. There is how we treat data We treat data as rows of data. We abstract away paging for you, and we package it as a subset. So there's a lot of abstraction going on to enable you to focus on the things that are most important for your application development. We do a lot of heavy lifting. And then there's a concept of columns, and you'll see that title address are examples of columns I separated, comma separated, and operate on this query, in this query, to extract these two specific rows of data. And this single element in itself is an example of projection. I'll just reach for that specific element in my return schema, data payload. What else? Well, so that's not it. That's pretty good. That gets you quite a way into our application development, and definitely quite a way towards our awesome application development. But you may want to say, how am I going to join sources? How am I going to get even more power out of this system? Well, enter subselect. Subselect goes out there, grabs that specific value, it returns it as a leaf node, and it's then used in fulfillment of this request to give you what you're after. It'll operate on HTTP protocol, so you really don't care where your data lives as long as it's HTTP accessible, which is yet again another level of how empowering YQL service is. We will do our best to parallelize the execution, which is, again, we're very performance-minded. The idea here is to return the fastest possible operation within the fastest possible time. And so the longest outstanding query within a timeout and so on and so forth. All of these concepts are baked into our request processing model. So what we're getting here is we're getting a weather forecast. We're picking a table, weather forecast, and we're going to say, oh, we're going to use this core table, which is sort of like an XML. If anything out there is an XML, that table will understand and process it. And we're going to pass this variable, which is the location where we expect that XML to sit at. And we're going to get our weather. If you were to drop it into YQL console, it works. It'll give you what you're asking. You can trust me, but hopefully you can try it on your own. So if that wasn't enough, right? And again, I'm only scratching the surface here to motivate some of the power that natively resides in the YQL box to empower you to build your awesome application. I'm not going to say it more than that, but I may still say it more than once, but don't hold it against me. It's all about the awesome application. So what do? Well, we've got these built-in functions that enable you to sort once your query has been fulfilled. It enables you to apply some unique operation, truncate, tail, reverse, sanitize, and so on. And obviously functions operate on the data return, so this is post-operation consumption. An example, sort, get your data, sort, and field nickname. So how do you benefit with this arrangement? Well, first of all, it's really easy. It's as simple as select star from a specific table of interest. What do you get? You get these verbs which enable bidirectional operation on top of your data store, which may be defined by your table, which happens to be your custom table, which, as Josh will cover later, is referred to as an open data table. What else you get out of it? Empowerment. Really, you're empowered to do all the stuff that I said is not easy to do. You worry about single document. You're empowered to use all these great features which are available at scale to everyone concurrently. And you get to focus on your application. But let's say you also wanted to add something in the middle because the table and XML abstract is not good enough as a container for what it is that you're after. You can add execute within YQL. And Josh will cover a little bit of execute. Megesh and Paul in their 2 subsequent sessions tomorrow and Wednesday are also going to dive into it. Execute is server-side JavaScript by YQL. You can extend, mutate your data right there in the pipe before it's returned to your client application. So let me just sort of recap this a little bit. So what is YQL? It's a cloud-like web service with SQL-like language. Or it's a cloud web service. It's cloud-like, cloud. It's debatable. It's familiar to developers. SQL language is familiar. It's been around for decades. I was reminded by one of the guys at 70s or so, I think. Does anybody know exactly how long has SQL been available for?
About 30 years.
There you go. Thank you. Get a free t-shirt, right? T-shirt. It's synonymous with data access. SQL is synonymous with data access, and it's sort of expressive in that sense to get the right data. Self-describing, show, describe table. It allows you to do what I just described YQL does, which is filter, join, query, and update data across the web. You can also use Yahoo storage. If you were to navigate to developer.yahoo.com and look at the guide, you'll see that you have some storage functionality available. All of this is available in real time. Request arrives, we process the request very quickly, as you'll see from one of the examples, and just return it back to you. All in real time. We do a lot of optimization. You get to inject business logic. I mentioned this before. This is non-trivial because you really get to shape and fashion your data before it's on the way out to the consumer or to your application. So in the spirit of recap, YQL launched October 2008. It's been around for a while. It's really not that long if you think how much work we've done and how much effort's been put into place and how much work is still going on. It's an actively developing, evolving platform at Yahoo. That's incidentally made available for free to all of you. These are some of the features in a timeline that you see kept evolving. You'll see that execute was some of the early features, early 2009, and yet you may have never known that YQL had JavaScript server-side for almost a year and a half. So this isn't news to us, whatever is going on right now. We've had it for a while, and we're very comfortable with this. You'll notice that there is a lot of cool stuff that's been done sort of throughout this timeline. But the funny thing, the most interesting thing, the mind-boggling thing is that this last bullet here, that speaks to how many open tables have been contributed since launch. And for those of you who may have not seen console, I'm not going to make you guess, but maybe I could make you guess. No, I'm not going to make you guess. It's almost 800. So if you look at the number of days elapsed, it's more than a table a day since launch that someone out there has added into YQL open data tables. There's also those tables which aren't surfaced. There are those tables which some of you have created just specifically for your needs, and that's what I call an iceberg picture. There's a good chance with the amount of traffic and the amount of usage we get, which I'll quickly allude shortly, that there is that level of tables which are sort of served out of your own endpoints. So where are we today? Where is YQL today? Well, how popular do you think it is? I mean, it's launched over a couple of years. We had few table requests when we launched, and sort of that's sort of how this is kind of how it stacks up. This is how popularity of YQL stacks up over the last year and a half plus. What is that number? Well, it's about 6 billion, almost 6 billion requests in October alone. In the first 7 days of November, we're on track for 7 billion, and I can only attribute this to YUIConf and the excitement that it generated out there. So a lot. This is a lot of requests. And what are some of the most popular tables, you may ask? Well, believe it or not, it's the XML table, which is straight out of the box with your own endpoint table available for you to use. Second most popular, which is interesting, is HTML, which means to me that there's a high demand for customizable API, which makes sense. You want to have your applications as innovative as possible, so there are multiple flavors by which you get at the data out there, which happens to be most commonly represented in HTML format. And this sort of goes through its RSS, CSV, JSON, and this particular graph ends with Mimi. Anybody knows what Mimi is? 5 people? So Mimi is a Yahoo social product. Check it out. Shameless plug. So that's sort of the recap. And now I'm sort of easing us into how best to take advantage of YQL and how to use it, how to effectively use YQL. And we enable this through YQL console. YQL console is this you'd expect of any powerful developer language to come with a console. And it's no surprise YQL comes with a console. So console is there to enable you to get going with YQL, but also is there to let you debug. It lets you create those queries, it lets you preview those queries, and lets you play and explore. And as Josh pointed out, it's a Swiss Army knife for YQL developers. So for those of you who like Swiss Army knives and who have a picture of Swiss Army knife, it's got a lot of tools in it, and that is very true for a console. Well, let's take a look at the YQL console. This is a reasonable picture. Actually came out better than I'd expect. We've got show tables. We've got your syntax highlighter. Thanks, Paul. Very nicely done. This is really easy to read. You've got your, like you'd expect in any console, a number of modules off to the side that sort of guide you through the process. So I'll very quickly step through this to just get you going. Point to some of the interesting features that we have in a console, and then I'll hand it off to Josh. Show tables, it does what it says. It shows you tables available in our system. It incidentally also has this nifty feature, which is a permalink, which lets you bookmark or use that shortcut for later use. You can also alias your query. There's a functionality off to the right, which if you were to click query alias, you get to name your queries for later recall. It's an easy way to get back to the queries that you were most interested in. What else? We've got your example queries. You can sort of browse through these in a top-down fashion to explore the console, explore YQL, play with YQL, and inspect in this center view what the result looks like. We have a handy search tool that will provided you enter your keyword, will go out there and fetch something that matches that keyword, which is a quick search. It lets you go for HTML in this specific case and gives you whatever matches that particular keyword. So once you enter your statement, you can test it. But not only you can test it, you can actually add diagnostics to it. Or you can look at it in a JSON format. So there is some toggle there as well. The one interesting thing you'll notice that we give you, speaking of performance, we give you user time. That is the time that you experienced interacting with YQL. But what we also tell you is how long a guy downstream took to get us this data that you asked for. All right? So where's YQL time in all of this? It's a delta between the two. And it's just over 50 milliseconds. So for the total user time, YQL took 50 milliseconds to do all this work for you. And if you look at the statement, it's not a trivial amount of work. So we do our work very quickly for you. Downstream sources all the time, if not, most of the time, if not all the time, are the ones that are going to essentially be tying us up. And so right there at the bottom, you also have the REST query. REST query is what you want to use in your application at the end of the day. That is the data fetch REST instruction. And last, there is this new addition to a console. If I were to go back to your previous slide, you'll see that there is this RSS multi-list tab right there. And that tab is what I call what we call presentation broken. What I call Query Builder and Explorer. Thanks to our own Paul Donnelly, this is an amazing feature that gets you going even easier with YQL. And here is an example of local search table. You see the types of calls or bindings which are made available and how you construct a query. What it lets you play with is also visually build that query, sort of yet another easy step into YQL query building. And that's where that tab is. That's how you invoke that feature. Covered that. So, what does it mean? That means that it's time for me to hand this over to Josh. Josh will take us through YQL in practice. It'll be a little bit more in-depth review of some of the features. And as I'm talking, we'll switch mics.
Thank you, Mirek. Excuse us for the little microphone switch off here.
Just put that, hang it on your pocket or put it in your pocket.
All right, sounds good. Well, thanks, Mirek.
No problem, Josh.
Excellent overview of YQL. So what I want to do for you guys, so this, I cheated. I looked at all the other YQL presentations that are coming out. And every one of them have this question: what is YQL? And I'm going to answer this in my words. So, well, first I want to say what the actual encyclopedia-like definition of YQL is. It's an expressive language that lets you query, filter, and join data across web services. Well, okay, that's good. What's that mean? So to me, it means that you can be lazy. You let YQL take care of the data and allows you to do what you want to do, which is innovate on APIs, not have to worry about each individual API. So Mirek covered this. This is very good. So what I want to do in my little talk is kind of take you through a practical example of how you would use YQL to solve a problem for you. So I'm going to touch on basically the development cycle, the ideation phase, I guess. Well, I'm going to ideate for you, but and take you through the actual discovery phase and how to implement an open data table. So the problem that I chose for myself, which I think I can solve, is fetch the Yahoo News articles for Twitter trending topics in a locale, and the locale I chose was San Francisco. So, I mean, we could all think about, probably every one of you maybe thought about how you would solve this problem yourself. I don't know how many of you thought about using YQL for it. Maybe not many because you're here learning about it, but I'm gonna be lazy. I'm gonna use YQL. And since I wrote part of YQL, this is very easy for me to do, hopefully. Okay, so again, a little bit of a recap of what Mirek was talking about. YQL tables. So we give you a ton of tables in the YQL console before you even have to start extending YQL. This is called the built-in tables. So there's a lot of properties that have provided data bindings, and they're actually present in the YQL console that Mirek showed. You do show tables, you'll see things from fantasy sports, from weather, from answers, Flickr, mail. You can do a lot of stuff with that. One of them up there is search. So search actually provides an interface where we can search for news articles. So that's going to be a key to what's going to be upcoming in our solution. Also the data tables. Data tables, again, two out of the top 3 most popular tables that we have are the HTML and XML table. Excellent generic APIs where you can point it to any HTTP web source and have it pull back, either pull in HTML and output XML or JSON, or just pull in straight XML. So before you even have to start writing an open table or anything like that, you can lots of times use those data tables. Okay, so this is an illustration of describe. Mirek talked about describe. YQL is self-describing. So I know that there's a search.news table. I told myself there was. So I do a describe on it. I want to see actually how to call it. So the describe provides meta information about the table, showing who wrote it. Obviously, Yahoo Inc. did. Shows a documentation URL. That URL is actually the URL that probably the developer of this table used to create the binding. And it gives you a sample query. Sample query is actually hugely powerful. Sometimes people don't even want to see the describe. They just want to see how it works and kind of go from there. So it kind of takes two brain patterns of people. People who want to see an example and maybe extend from the example. People who maybe want to see the documentation behind it. So the documentation, in this example, we see that the query is a required parameter. And that's going to be the one that we're going to end up using in our sample. OK. So Twitter trends. So we obviously don't have a built-in table for a lot of the Twitter stuff. But I realized that Twitter provides an API to do this. So what do I want to do? I want to create an open table to map to the API that Twitter provides. I do this by using YQL open tables. YQL open tables brings the power of YQL to any API. And it does this through a schema element, or a schema document. Schema document is basically the binding between any API that's out there and the specifics on what YQL needs to do to call that, and allow you to bind a YQL query to the actual API. So very powerful. And just specifically, you can, a little technical detail, you include your YQL open table with a use element or an end element. So we'll get to that in a second. So again, I might be going over this stuff kind of fast, so if anyone has questions, just please stop me and we can go over it more in detail. Okay, so I realized that I needed to create an open data table for my Twitter trends. So this is kind of a long step that we just took in one slide. But here's an actual complete open data table definition for the Twitter trends. So, I mean, depending on your comfortableness, if that's a word, with XML, it could seem pretty simple. I mean, there's not too much going on in here. We can see that schema document that I talked about is being imported. So that gives the structure of the XML. And then also we have, kind of a few things that are specific to the Twitter API, and two of which we're going to talk about in the next slide. So I want to focus in on two elements. So the URL element is kind of the basis for calling an API. It tells YQL where to go when you're calling this API. You can see that the Twitter API, you can see the URL up there for it, and we can see this one little kind of curly braced WoID thing at the end. So that obviously, you can't make the call like that. That would result in some sort of 404 or something like that. What that actually ends up being is a placeholder for YQL to insert a key. So the key, which is on the next line, is the actual definition of what gets substituted into that URL. So the WoID, the name of it, is a param type of path. Path means that it gets inserted into the actual URL that you have up there. There's another type of params, which are also query parameters. So say, fictitiously, let's say that there was another key that we wanted to add to this Twitter trends, say like language or something like that. We could define another key, and the param type would be query. And what would happen is on that URL, you'd end up kind of appending query parameters onto that. And obviously the last element being required is telling YQL, when we compile this query at runtime, that this key must be present for the query to run. The presence of this obviously enforces the YQL parameter. You'd get an error if you didn't provide this. And of course, if you didn't have this attribute on this particular field, it would become optional. OK, so now we've created our open data table. So now we want to run this guy. So what do we do? OK, so Mirek talked about how you run things. The console is fantastically powerful for you to quickly design and develop things. Mirek showed you examples of it. I don't want to go over that again. The URL's up there. You can go to it. So actually, when it gets down to the nuts and bolts of making a request to YQL, you're going to end up making a web service call. We have two endpoints, public endpoint and authenticated endpoint. Pretty self-explanatory. The public endpoint, no authentication requirements. And there's also a 1K per hour rate limit. Authenticated endpoint, slightly different. You can see that the public is not on the bottom one. Requires OAuth. So it is authenticated. Because it's authenticated, we end up trusting this user a little bit more because we know who they are. We give higher rate limits to that person or application. So we can see that actually to pass in your YQL query, it becomes a Q query parameter on the URL. So it's as simple as that. That's the URL that you can get. In this example, it's a show tables. You can conceive that being anything, any select statement that you saw previously from Mirek's presentation, and also what we're going to end up doing later could go on to that. Illustration, YQL accepts gets. This example, that curl would return you results. Also accepts put, post, and delete. So that second curl would also be roughly equivalent response of the first get, or the first curl. Okay, so now we got some details out of the way. So this table that we just created. So let's run this thing. So I know I mentioned that we want the Twitter trending data, and we want it from San Francisco. Well, I cheated. I know what the WOA ID is for San Francisco. WOA ID, if anyone's not familiar with it, it's Where on Earth ID. It actually comes from our good fellows over at the Yahoo Geo team. It gives a numeric ID to any point on Earth. And so it's actually, I encourage everyone to go check out Yahoo Geo. It's a fantastically powerful thing. But in this case, WOA ID, that number up there, relates to San Francisco. So what do we get back? So first of all, let's take, I guess, at the very top in the query, we can see that we did a use. The use pulls in that XML binding that we actually created a few slides ago. That allows YQL to bind to this query that we end up passing in the select. So at runtime, we can see that we get trends from San Francisco. And as far as I can tell, I don't really see anything specific about the locale. Maybe the actual results, Keith Olbermann, maybe a few movie things like due date. I don't know. I don't know exactly why San Francisco is trending about some of those things. One thing I notice about this as well is that we get kind of a mixed response. We get some, for those of you who can't see it, we get names like Oscar Grant. And then we also get some hashtag things. I can't live without something. Well, of course, if I'm going to pass in a hashtag to the Yahoo News service, it's not going to know what that is. I mean, no web service is going to get these hashtags. I don't know. People just make these things up. So I decided on my own that I want to get rid of these things before I actually make that call to the Yahoo News web service. So how would I do that? So Twitter doesn't actually allow you to selectively pull things back based on that parameter. There's nothing that you can do to control that. So I'm going to either have to do that in my application before I make the call to Yahoo News, or I could use YQL execute. So YQL execute allows you to extend your table with custom application logic. So that ends up being Java server-side scripting. Server-side scripting, no DOM. You can't do anything. This isn't the UI, so there's no need for that. It's also E for X compatible. Not going to get into too many details about E for X, but it's ECMAScript representation, or XML representation in ECMAScript. So YQL also provides in your execute element, it provides some kind of utility objects that allow you to do some things that are specific to the YQL execute. Request, response, y.rest, y.include, y.query. Not going to get into all of them, but I assume that in the subsequent talks about YQL execute will probably be broached in that topic. So what did I do? I created the execute. So I assume this is a UI conference. Everybody's familiar with JavaScript, probably more familiar than I am. So I wrote this last night. So what it does really, and I'm hopefully don't scrutinize my code format, but what that top level under the execute does actually makes the web service request and gets an XML response back. Yes, it does. OK, so it iterates through the trends that come back, what we saw in that YQL query in the console, searches for something that starts with a hashtag, and if it does this delete that element. That's actually E for X to just drop that element. The very last line, after you've manipulated your XML, after you've changed things, renamed, whatever you want to do, you set the response object back to your XML document. That is the actual point where you hand the data back to YQL, and it can then again operate as a standard YQL table on that. So the result of this, now we run our handy-dandy use on my execute table. Execute table, you can see there's no hashtags in it. So we've removed the hashtags. What that's going to do, it's going to save me a few requests from that I would have made to Yahoo News that I know wouldn't have returned data. So I get to remove 3 of those in this particular case. So I don't make these 404 calls that I know aren't going to respond with anything. So that's an example of using execute to enhance, to streamline, to do whatever you want to do in YQL execute. OK, so really briefly, I'm going to talk about community tables. Really briefly. Community tables. So I wrote this table. I think it's useful. Now I say, well, I mean, I'm not just going to keep this to myself. I want everyone to use it. And we have a mechanism for this as well, which is the hosted community on GitHub, and actually also mirrored on datatables.org. Datatables.org is a place where all the tables are hosted, and you can actually, in your queries, you can use this env query parameter that we talked about previously to get all the community tables in at once. People aren't familiar with GitHub. This is actually the YQL repository on GitHub, standard stuff if you've seen GitHub. And also, here's the mechanism that I would actually go to contribute. So 1 through 5, that is also standard Git stuff. I'm not here trying to do a full tutorial on Git, but 1 through 5 is kind of a standard request that you'd go and do it. Number 6 ends up being the special step. Once you do a pull request, you put your changes into GitHub, you request a pull. The table admins actually pick that up, and they would merge that in and actually kick off the process that would get it added to datatables.org. So now I've got my new handy-dandy Twitter trending topic loaded on the community tables. So now what does my query look like? So here's the final result. So you see that execute that we created? It's in there. WO ID for San Francisco. We take the results from that, which is the trend, which is that topic that we saw that doesn't have any hashtags in it. Pass that back to the Yahoo News query. So this ends up being one HTTP call out from your application, which probably makes up to 10 requests in the resulting service, one to the Twitter and then to the Yahoo News. Also takes multiple XML fields from the search.news response, filters it down just to the ones that we care about. So then here's our end result. So we have 70 requests. We have all Twitter trending data, or trending news articles in San Francisco from Yahoo News. So, oh, excuse me. That was my ending comment. So, in conclusion, YQL is very powerful, and I encourage all of you to be lazy and use YQL to get your jobs done easier.